Hello everyone, we are back once again. Today we are looking at a new version of the USB Isolator board that I've shown you in the past. We are here in KiCAD. We are specifically running a build of KiCAD from November 28th of last year. I build it from source, so if things are a little bit different, that's what it is. KiCAD's gone through a lot of changes in the last couple of months, and so you'll notice that some things are different. But anyways, let's get right into it. So going into the schematic here. If you didn't check out the video a long time ago that I released about the USB Isolator, this is basically just a extension of it. The original board was actually wrong in many aspects. I didn't even finish fully building it up before realizing that it just wasn't going to work out. I wasn't paying enough attention when I was laying out several components, and I decided to expand on things a little bit. So the core of the USB Isolator here is the Analog Devices ADUM4160. It's a low and full speed USB Isolator chip. So basically you put your USB in one side and power it, and then a different power source and USB out on the other side. So it's got like a little transformer action going on inside it. So while we're talking about that chip, there's actually I mentioned that it's for low and full speed, not high speed or whatever the term is for USB 3.0. I can't remember, or USB 3. So it actually doesn't go up to the full 480 megabits per second for the high speed. So this is actually like USB 1.1 speed. Nobody has made an isolator chip that can handle that higher speed. So this is just for like low data rate applications. But anyway, sometimes you need things to be isolated from each other. You don't want, say, some sort of digital analog converter to share a common ground with your PC, right? So you actually have to select if it's going to be low or full speed. So that's through these resistors right here that I've got. So one on both sides, so SPU and SPD. And I just have them permanently set to full speed, because nobody wants to use low speed. If your device, there's very few devices that even are still around that only support low speed and not at least full speed. So I just was like, whatever. Another thing that you'll notice right here is that this says right here, simulate device disconnect button. So if you pull this one pin on the device called pin to ground, it will actually cause a USB disconnection event on the host. So this lets you effectively unplug and replug in your device without having to physically do that, because with the isolator you would have to, under some circumstances you would actually have to unplug everything. So you'd have to unplug the host side from the one side of the chip and the device side, your device from it, just to power cycle everything and whatnot. So this just causes an actual USB disconnection event, and then you don't have to worry about it. Another feature that I put on is that there's actually now both for the upstream side. So from your PC, for example, there's USB-B and there's micro B connectors. Both just they're put in parallel. You shouldn't really be doing that, but this isn't high speed USB. So the effect of the shunts, you basically have like a little waveguide just like sitting off of your main data line if you have something not connected, right? So if this was not connected, you would just have some traces just hanging out there, acting as a shunt of some sort, right? So you normally wouldn't be doing that, but this is a low enough speed that it doesn't really matter. So you've got them both in parallel just to give you the option. But also for the power side, you can bypass the linear regulator now, and you can just use a micro USB connector and have that connected to one of those power cubes that that like everybody has these days because of cell phones and tablets and whatnot. So you can just use that as your 5-volt source for your isolated device side. So those are the main changes, and I'll just show you this real quick. This is what the new the new CV-PCB tool looks like. This is your footprint selector in KiCAD. It's very different. It took me a little bit to get used to it, but they've redone a lot of their packages and whatnot, and the libraries in general. But I won't go into that. Just something to keep in mind if you are looking to upgrade to the latest version. So if we go ahead and load up the schematic here, I've changed up a lot of things. I've changed all the footprints to 0603 parts. I've also properly routed the linear regulator. I just took the default footprint, like the pinout, and the pinout was wrong. I should have looked at the datasheet, of course. And same thing with the DC barrel jack. That one's actually correctly set up now. So you can't see the ground. I just have the ground plane turned off right now, but everything is flooded there. So as you can see, now it's like as much separation between the two ground planes as you can get, and I think that's more even than what it asks for in the datasheet. But honestly that's as much as you can get almost, other than this one little trace hanging out here off to the side, right? Because the highest amount of isolation you're going to get is the distance between the pins in this package anyway. So let's just turn that off so we don't have to look at it though. I did notice one problem in this design, and I will show you guys in a second, but that'll be corrected for when I actually ship it. It's a thing that's not going to impact the functionality. But let's go ahead and take a look at the 3D display of this, and it gives me an error just because I did something stupid, but the error is not important. So I don't have 3D models for everything, but this will give us a good look. So here's the, sorry, I'm just trying to reorganize this here. So here's the isolator chip. This is going to be the actual bottom side. It's the top side in the layout here, right? So it's all the red parts are your quote top layer, and green is your bottom layer copper. But in practice, this is going to end up being on the bottom. And if we flip this over, you'll see that we've got our USB connectors. So if we just rotate this a little bit, there we go. So we've got host USB-B and host micro USB. So I don't have a 3D model for the micro USB connectors there. So this will be the host side. This will be your two options for power. And this will be your device, right? And this is where the little reset switch will go. So this whole board actually fits into a little box that I found. I designed it for the same size of it, so 2 screws will go through here, and so it's like a little box, and this replaces the lid. So if you've seen the micro current from the EEV blog from Mr. Dave Jones there, he does the same sort of thing, right? He gets a little jiffy box and takes the lid off, gets rid of the lid, and uses the PCB as the lid to the box. And in this sort of similar situation, right, he puts the switches and whatnot and connectors on the top side and puts all of the ICs and passives and whatnot on the bottom side. So that goes into the box so you can't touch them. So that's pretty much the extent of the board. The mistake that I noticed is right here. Actually, I didn't notice how close I made that one resistor to the USB-B connector. So I'll just have to cover that off just for testing, and then move that slightly for the actual version that I get made for my website. But I'm using a low dropout linear regulator too, so it should support about 6.1 volts and above. So if you put in 6.5 or something, but if you're going to draw any actual amount of current, it's probably just a better idea to use a charger cube and just bypass the regulator entirely, so you don't have to worry about heat problems and whatnot. This is all open source, of course. It's all open source hardware, so you can get it off of our GitHub page, github.com/Galvant. Links in the description below as normal. And that's pretty much it. So they just shipped from OSH Park a couple days ago. I got another board that was shipped also, or just got back from the fab today, so might ship today. Might ship I don't know, maybe on the weekend or on Monday or something. So since I'm in Canada, though, it takes some time to get here. So it'll be here in maybe another week and a half, and then I'll be able to show you guys on camera what the isolator looks like. Alright, that's pretty much it, and I hope you guys enjoyed this, and I will see you all next time.